Imagine a place so cold, so remote, and so inhospitable that for centuries, it remained untouched by human presence. A frozen continent locked beneath kilometers of ice, where temperatures plunge below -80 degrees Celsius and the sun disappears for months at a time. This is Antarctica. At first glance, it appears silent, lifeless, frozen in time. But beneath this vast white expanse, something strange is happening. For decades, scientists believed Antarctica to be little more than a frozen desert, a continent whose secrets were buried under thick sheets of ancient ice. But as technology advanced and researchers began to peer deeper below the surface, they started to uncover something unexpected. Hidden beneath the ice lies an entire world. A world of liquid water, underground lakes, and mysterious geological activity that defies everything we once thought we understood about this frozen continent. And perhaps most intriguing of all, this hidden world is changing. The deeper scientists looked, the more they realized that Antarctica is not as still as it seems. Beneath the silence, beneath the ice, something is shifting, slowly, quietly, but undeniably. To understand this mystery, we must first step back and look at how Antarctica came to be. Millions of years ago, Antarctica was not the frozen wasteland we know today. It was part of a supercontinent known as Gondwana, a vast landmass that included what is now South America, Africa, Australia, and India. Back then, Antarctica was warmer, covered in forests, teeming with life. But over tens of millions of years, tectonic forces began to pull the continents apart. Antarctica drifted southward, isolating itself at the bottom of the planet. And as it did, something remarkable happened. Ocean currents began to circulate around the continent, forming what scientists now call the Antarctic Circumpolar Current, a powerful ring of water that effectively cut Antarctica off from the rest of the world's warmer oceans. This isolation triggered a dramatic cooling. Ice began to form. At first, slowly, then rapidly. Layer upon layer of snow compacted into ice, building over millennia into a vast ice sheet, one that would eventually reach thicknesses of over 4 kilometers. Today, this ice sheet holds around 70% of the world's fresh water. But what lies beneath it remained a mystery for most of human history. It wasn't until the late 20th century that scientists began using radar and satellite imaging to peer through the ice. What they discovered was astonishing. Far below the surface, hidden from view, were vast lakes of liquid water. One of the most famous is Lake Vostok, a body of water buried beneath nearly 4 kilometers of ice, larger than some of the world's largest freshwater lakes. At first, this discovery seemed impossible. How could liquid water exist in one of the coldest places on Earth? But scientists soon found the answer. Pressure. The immense weight of the ice above creates pressure so great that it lowers the freezing point of water. Combined with heat rising from the Earth's interior, it allows these lakes to remain in a liquid state, trapped in darkness, isolated from the surface for millions of years. But Lake Vostok was just the beginning. As researchers continued their investigations, they uncovered hundreds of these subglacial lakes scattered across Antarctica. Each one hidden. Each one isolated. Each one potentially holding secrets from a world long forgotten. And then, something even more unexpected emerged. These lakes were not static. They were moving. Satellite data revealed that water beneath the ice was flowing, sometimes rapidly, between lakes, forming an interconnected network of subglacial rivers and channels. It was as if an entire hidden hydrological system existed beneath the frozen continent, a system no one had ever imagined. Scientists began to realize that Antarctica wasn't just a frozen block of ice. It was dynamic, alive with motion beneath the surface. And this movement had consequences. As water flowed beneath the ice, it acted as a lubricant, reducing friction between the ice sheet and the bedrock below. This allowed massive sections of ice to slide more easily toward the ocean. In some regions, glaciers began to accelerate. Ice shelves started to thin. And in certain areas, the changes were happening faster than expected. But something still didn't add up. Because in some parts of Antarctica, researchers detected heat, far more than they had anticipated. This wasn't just the slow geothermal warmth of the Earth's crust. In certain regions, there were signs of something more intense. Something unusual. Something that suggested that deep beneath the ice, the Earth itself might be more active than anyone had realized. Scientists began to map the bedrock beneath Antarctica in greater detail. What they found was surprising. Hidden under the ice were mountain ranges, valleys, and even vast rift systems, regions where the Earth's crust is slowly pulling apart. One of the most significant of these is the West Antarctic Rift System, a massive geological feature stretching thousands of kilometers beneath the ice. Rift systems are often associated with volcanic activity, and this raised an unsettling possibility. Could there be volcanoes beneath Antarctica? The answer, it turns out, is yes. Dozens of them. In fact, Antarctica is home to one of the largest volcanic regions on Earth, most of it buried beneath ice. Some of these volcanoes are dormant. Others may not be. And as researchers began to investigate further, they found evidence that some of these subglacial volcanoes might still be active. Heat anomalies, seismic activity, unusual melting patterns beneath the ice, all pointing toward something happening deep below. But what they discovered next was even more surprising. Because in certain regions, the melting of ice wasn't just gradual, it was accelerating. And the source of that melting didn't always match what scientists expected. In some areas, the pattern suggested that heat was rising from below, not just from the atmosphere above. This meant that the changes happening in Antarctica might not only be driven by climate, but also by forces hidden deep within the Earth itself. For scientists, this changed everything. Because if the base of the ice sheet is warming, it could fundamentally alter how the entire system behaves. It could speed up the flow of glaciers, destabilize massive ice shelves, and potentially contribute to rising sea levels in ways we are only beginning to understand. But even as these discoveries raised new questions, they also revealed something else. Something far more mysterious. Because beneath the ice, in complete darkness, under immense pressure, and isolated for millions of years, there may be life. And not just simple microbial life, but ecosystems, entire biological communities, existing in one of the most extreme environments on Earth. The deeper researchers looked, the more they realized that Antarctica's hidden world was not just a geological mystery, but a biological one as well. And what they would uncover next would challenge our understanding of life itself. For years, the idea of life existing beneath Antarctica's ice sheets seemed almost impossible. The conditions were simply too extreme: complete darkness, crushing pressure, near-freezing temperatures, and isolation from the outside world for millions of years. And yet, scientists began to find evidence that life not only existed there, but had adapted in ways no one had ever seen before. The first clues came from samples extracted from subglacial lakes and the sediments beneath them. When researchers analyzed these samples, they discovered microscopic organisms, bacteria and archaea, living in complete isolation. These were not ordinary microbes. They were extremophiles, organisms capable of surviving in environments once thought to be completely uninhabitable. But something about them stood out. They were not relying on sunlight for energy. Instead, they were surviving through a process known as chemosynthesis, deriving energy from chemical reactions involving minerals and gases from the Earth's crust. In other words, these organisms were living off the planet itself. Scientists began to realize that these ecosystems were more similar to those found near deep-sea hydrothermal vents than anything on the surface. And this raised a profound question. If life can exist here, beneath kilometers of ice, cut off from sunlight, then where else might it exist? But before they could answer that question, researchers needed to understand just how extensive these hidden ecosystems were. And that's when things became even more intriguing. In recent years, drilling projects have allowed scientists to access some of Antarctica's subglacial environments directly. One such effort involved drilling into Lake Whillans, a subglacial lake buried beneath 800 meters of ice. What they found was astonishing. The lake was not sterile. It was alive. Thousands of microbial species were identified, forming a complex and active ecosystem. These organisms were not just surviving, they were thriving, cycling nutrients, and sustaining a delicate balance in total darkness. The deeper researchers looked, the more they realized that these ecosystems were interconnected, linked by the flow of water beneath the ice. Subglacial rivers were transporting nutrients and microorganisms across vast distances, creating a hidden biosphere that spanned much of the continent. But something else was happening. As the ice above shifted and melted in certain regions, these isolated ecosystems were beginning to change. Water flow patterns were altering. Nutrient cycles were shifting. And in some cases, entirely new pathways were opening beneath the ice. Scientists began to realize that the hidden world beneath Antarctica was not static, it was evolving. And the forces driving that evolution were both external and internal. On one hand, climate change was affecting the surface, warming the atmosphere and oceans, leading to increased melting at the edges of the ice sheet. On the other hand, geothermal heat and possible volcanic activity beneath the ice were influencing conditions from below. Together, these forces were reshaping the subglacial environment in ways that had never been observed before. But perhaps the most surprising discovery came when researchers began studying the sediments beneath these lakes. Buried within these sediments were chemical signatures, traces of ancient biological activity that suggested these ecosystems had existed for far longer than anyone had imagined. Possibly for millions of years. This meant that the life forms beneath Antarctica had been evolving in isolation for vast periods of time, developing unique adaptations that could provide insights into the limits of life on Earth. And perhaps beyond it. Because the conditions beneath Antarctica bear a striking resemblance to environments that may exist elsewhere in the solar system. For example, Jupiter's moon Europa is believed to have an ocean beneath its icy surface. Similarly, Saturn's moon Enceladus has shown evidence of subsurface water and hydrothermal activity. If life can exist beneath Antarctica's ice, then it is no longer unreasonable to imagine that it could exist in these distant worlds as well. But as scientists explored these possibilities, they were also confronted with a more immediate concern. Because the changes occurring beneath Antarctica were not isolated phenomena. They were connected to the global climate system. As subglacial water flows increased, they began to influence the movement of ice above. In some regions, this led to faster glacier flow, transporting ice from the interior of the continent toward the ocean at an accelerated rate. And when this ice reaches the ocean, it melts, contributing to rising sea levels. But something about this process was becoming increasingly unpredictable. In certain areas, glaciers were accelerating far more rapidly than models had predicted. In others, ice shelves were thinning from below, weakened by warm water intruding beneath them. Scientists began to suspect that the interactions between surface warming, ocean currents, and subglacial processes were more complex than previously understood. And then came a discovery that would deepen the mystery even further. Using advanced radar and satellite data, researchers identified regions beneath the ice where melting was occurring at unusually high rates. These hotspots did not always correspond to known geothermal features or oceanic influences. In some cases, the source of the heat remained unclear. This raised a troubling possibility that there may be processes occurring beneath Antarctica that we do not yet fully understand. Hidden mechanisms influencing the stability of the ice sheet. Mechanisms that could have significant implications for the future of the planet. The deeper scientists looked, the more questions emerged. What exactly is driving these changes beneath the ice? How extensive are the hidden ecosystems that exist there? And perhaps most importantly, what happens if this delicate balance is disrupted? Because if the forces beneath Antarctica continue to shift, if the ice becomes increasingly unstable, it could trigger changes that extend far beyond the frozen continent itself. Changes that could reshape coastlines, alter ocean currents, and impact ecosystems across the globe. And yet, despite decades of research, much of Antarctica's hidden world remains unexplored. A vast, unseen frontier beneath the ice. Silent, isolated, and still full of secrets. But something is happening down there. Something that scientists are only just beginning to understand. And as new technologies allow us to peer deeper into this hidden world, one thing is becoming increasingly clear. The story of Antarctica is far from over. In fact, it may only just be beginning. In fact, it may only just be beginning. Because as scientists continue to unravel the mysteries beneath Antarctica, they are beginning to realize that this frozen continent may hold answers to some of the most fundamental questions about our planet and our place within the universe. What was once thought to be a static, lifeless expanse is now understood as a dynamic system, one shaped by the interaction of ice, water, rock, and life. And at the center of it all lies a fragile balance. A balance that, if disrupted, could have consequences on a global scale. To understand what lies ahead, researchers are now focusing on the future of Antarctica's ice sheets. These vast bodies of ice act as a stabilizing force for Earth's climate. By reflecting sunlight back into space and storing enormous amounts of fresh water, they play a crucial role in regulating global temperatures and sea levels. But something is changing. Over the past few decades, satellite observations have revealed that parts of Antarctica are losing ice at an accelerating rate, particularly in West Antarctica. Glaciers such as Thwaites and Pine Island have shown signs of instability, retreating faster than expected as warm ocean water erodes them from below. But something changed. Scientists began to realize that the behavior of these glaciers could not be explained by surface warming alone. Instead, the answer seemed to lie beneath the ice. Subglacial water systems, geothermal heat, and the shape of the bedrock itself were all influencing how ice moved and melted. In some regions, water pooling beneath the ice was acting like a lubricant, allowing entire sections of the ice sheet to slide more rapidly toward the sea. In others, hidden valleys and basins were channeling warm ocean currents deep beneath ice shelves, accelerating melting from below. The deeper researchers looked, the more interconnected these processes appeared. It was not a single factor driving change, but a complex network of interactions, many of which were still not fully understood. And this complexity makes predicting the future of Antarctica incredibly challenging. Because small changes in one part of the system can trigger cascading effects elsewhere. A slight increase in subglacial water flow could accelerate a glacier. A minor shift in ocean currents could destabilize an ice shelf. And once certain thresholds are crossed, the changes may become irreversible. This has led scientists to consider the possibility of tipping points, critical moments at which the ice sheet could undergo rapid and irreversible transformation. If such a tipping point were reached in West Antarctica, it could lead to the collapse of large portions of the ice sheet, raising global sea levels by several meters over the coming centuries. For coastal cities around the world, this would be transformative. But even beyond the implications for sea level rise, Antarctica's hidden world offers something else. A glimpse into the resilience of life. Because the ecosystems beneath the ice have shown us that life can persist in conditions once thought impossible. They have revealed that energy does not always come from sunlight, that life can thrive in darkness, fueled by the chemistry of the Earth itself. And this realization has profound implications. It expands our understanding of where life can exist, not just on Earth, but throughout the universe. Planets and moons once dismissed as barren may, in fact, harbor hidden oceans beneath their surfaces. Worlds that appear frozen and lifeless from the outside may, like Antarctica, conceal dynamic environments beneath. But there is also a more immediate lesson to be learned. Because the changes occurring beneath Antarctica are not isolated. They are part of a larger system, one that connects the atmosphere, oceans, and solid Earth in ways we are only beginning to understand. And as human activity continues to influence the global climate, the delicate balance of this system is being tested. The question is no longer whether Antarctica is changing. It is how fast, and how far those changes will go. Scientists are now racing to gather data, deploying autonomous vehicles beneath ice shelves, drilling deeper into subglacial lakes, and using satellites to monitor changes in real time. Each new discovery adds another piece to the puzzle. But it also reveals how much we still don't know. Because for all our advances in technology, Antarctica remains one of the least explored regions on Earth. A continent where vast areas remain untouched, unseen, and largely unexplored. And beneath its ice lies a world that continues to surprise us. A world where rivers flow in darkness. Where heat rises from deep within the Earth. Where life exists against all odds. and where the forces shaping our planet are quietly at work. What they discovered next was even more surprising. Because in studying Antarctica, scientists are not just learning about a distant, frozen land. They are uncovering the hidden mechanisms that govern Earth itself. Mechanisms that influence climate, sea levels, and the stability of ecosystems across the globe. And in doing so, they are gaining a deeper understanding of the delicate balance that makes life on this planet possible. But perhaps the most important realization is this. Antarctica is not as distant as it seems. Its fate is tied to our own. The changes occurring beneath its ice sheets will not remain confined to the southernmost continent. They will ripple outward, affecting oceans, weather patterns, and coastlines around the world. And so, the story of Antarctica becomes something more than a scientific mystery. It becomes a story about the future of our planet. A reminder that even in the most remote and seemingly lifeless places, the forces of change are always at work. And that beneath the surface of what we see, there is always more waiting to be discovered. Because in the silence of Antarctica, beneath kilometers of ancient ice, something strange is happening. And we are only just beginning to understand what it means.